Welcome! In this video, we will introduce you to Simcenter HEEDS and guide you through the key steps for creating a successful design space exploration project. Creating innovative products is a demanding and multifaceted challenge. Engineers must navigate strict product requirements while minimizing costs and ensuring efficient manufacturability, a delicate balance that calls for ingenuity, precision, and advanced tools. Across industries, computer-aided design, CAD, and computer-aided engineering, CAE, have become indispensable in the product design process by enabling engineers to craft detailed virtual designs and simulate the physics that shape product behavior and performance. Over the past few decades, CAD and CAE software have revolutionized the design landscape, evolving into faster, more robust, intuitive, and reliable technologies. These advancements have transformed product development, empowering engineers to drive innovation and achieve heightened efficiency like never before. Meanwhile, leaps in computing hardware have made systems significantly more powerful and affordable. But here's the critical question. Is your organization fully leveraging the power of CAD, CAE, and modern hardware? The answer, for many organizations, is no. Key challenges often stand in the way. In an organization with a siloed mindset, disconnections between CAD and CAE teams or across different physics disciplines can hinder collaboration and stifle innovation. Lack of automation forces many organizations to rely on manual workflows, which makes computing design variations slow, costly, error-prone, and inefficient. Ultimately, the lack of automation often limits teams to evaluating only a handful of options, leaving a significant portion of the design space unexplored. The solution? In this video, we'll show you how Simcenter HEEDS empowers your organization to break down knowledge silos, streamline and automate workflows, and unlock groundbreaking possibilities hidden within your design space. Instead of focusing on just a handful of manual designs, Simcenter HEEDS smartly evaluates hundreds of them, leveraging advanced design space exploration techniques and workflow automation to intelligently search for solutions that meet your requirements while optimizing your key performance indicators. Simcenter HEEDS is best described through its four key enabling technologies. The first key technology is process automation. Starting with a mature, parameterized CAD and CAE model, users leverage portals to seamlessly connect Simcenter HEEDS with a wide range of commercial and in-house tools, creating a streamlined calculation workflow. Simcenter HEEDS offers more than 60 portals for commercial and open-source tools. Inputs and outputs are defined and integrated into the workflow, serving as the foundation for transitioning from manual to fully automated designs. The second enabling technology is distributed execution. Simcenter HEEDS orchestrates compute resources across Windows or Linux workstations, clusters, or cloud environments. This ensures the optimal utilization of hardware and software resources, accelerating computations without adding complexity for the user. The third key technology is efficient search. Simcenter HEEDS offers a diverse array of algorithms to intelligently and effectively explore the design space. Based on project requirements, users can perform various studies such as optimizations, design of experiments, adaptive sampling, reliability analysis, and more. Last but certainly not least is insight and discovery. Simcenter HEEDS equips users with advanced post-processing tools, combining intuitive visual analytics with powerful machine learning algorithms. These tools help uncover key insights, evaluate trade-offs, and support confident, data-driven decision-making. Now that we understand what Simcenter HEEDS is, let us explore how its workflow is reflected in the graphical user interface. The workflow in Simcenter HEEDS consists of 6 key steps: automating the simulation workflow, defining variables and responses, tagging variables and responses, setting up the design study, running the design study, and finally, gaining insights and discoveries. The Simcenter HEEDS user interface is thoughtfully designed to align with these steps, providing a seamless setup process for new projects. Each main step is represented as a tab in the main menu, arranged sequentially from left to right for intuitive navigation. The model files and their associated references can be conveniently accessed and organized through the vertical model tree, which provides a structured and user-friendly interface for navigating and managing the different components of the model. The first step in Simcenter HEEDS is to create the calculation workflow within the Process tab. This workflow, referred to as the process, consists of multiple analyses that are executed sequentially from left to right. These analyses are selected from the portal catalog, which includes more than 60 commercial and open-source CAD and CAE tools. users can effortlessly create analyses using a simple drag-and-drop interface. For each analysis, Simcenter HEEDS automatically generates the execution command and command options. Additionally, users can specify the computational resources to be used, such as a remote computer, cluster, or cloud system if needed. After users specify the input and output files, Simcenter HEEDS employs specialized scripts behind the scenes to extract metadata from the files. This automated process, known as parsing, ensures that all critical information is accurately identified and seamlessly integrated into the workflow for efficient and effective use. In the second step, users define the inputs, referred to as variables in HEEDS, and the outputs, known as responses, within the Parameters tab. This step ensures that all design variables and responses are accurately established for process automation. Variables are categorized into several types, with the most common being continuous, discrete, and dependent. Continuous variables require the specification of minimum, baseline, maximum values, and resolution. Responses can also be classified into different types, the most common being tag responses and formula responses. After defining the variables and responses, the next step involves navigating to the Tagging tab. In this phase, the parsed data extracted from the input and output files by the portals is used to associate, or tag, specific variables with designated sections of the input files. Similarly, responses are systematically tagged to corresponding output files, ensuring a precise connection between the simulation data and the workflow. Importantly, the Parameters tab and the Tagging tab are intricately linked, working together to streamline this automation process. These steps, along with the previous ones, comprises the process automation and distributed execution key enabling technologies in Simcenter HEEDS. Next, we turn our attention to how the efficient search capability integrates with the graphical user interface in the Study tab. In the Study tab, users are required to select a design exploration strategy that aligns with their project goals. Options include evaluation only, parameter optimization, adaptive sampling, design of experiments, or robustness and reliability analysis. Within this tab, users can also specify the method associated with their chosen study type. For example, the number of designs to be evaluated is assigned to the selected algorithm in this section. For optimization studies, objectives and constraints can be seamlessly defined by simply dragging and dropping the respective response onto the interface. Next, we move to the Run tab, where the calculation process begins and is closely monitored. Simcenter HEEDS provides real-time graphical feedback alongside detailed logs generated by the solver, ensuring users have full visibility into the progress and status of their study. During runtime, Simcenter HEEDS dynamically generates new variable values, which are then automatically used to overwrite the tagged sections of the input files. This process occurs before the batch execution begins. Once the execution is complete, Simcenter HEEDS utilizes specialized scripts to extract the tagged values from the output files and map them to the corresponding responses. Additionally, the Run tab allows users to efficiently reuse existing data from previous studies, saving time and leveraging prior work to streamline the exploration process. Finally, we arrive at the post-processing, or what we referred to as the insight and discovery key enabling technology. In this final step, the data computed by Simcenter HEEDS is transformed into know-how and is used to take well-informed decisions. The post-processing interface in Simcenter HEEDS Post is organized into several tabs, accessed sequentially from left to right. The left pane features a tree structure for intuitive navigation of various plots, such as history plots, 2D and 3D relation plots, parallel plots, heat maps, and more. These can be seamlessly synchronized into a single, interactive view for streamlined analysis. Beyond visualization, Simcenter HEEDS Post includes advanced statistical and machine learning tools for computing clusters. Trade-offs: influence, correlation, sensitivity, and more, empowering users to explore design data effectively and make informed decisions. For surrogate modeling, the dedicated Surrogate tab automates the creation, comparison, and evaluation of surrogates, providing efficient workflows and quality assessments for reliable analyses. As we near the conclusion of this video, Let's take a moment to recap its main concepts by mapping the 4 key technologies to the 6 steps within the Simcenter HEEDS graphical user interface. The process automation and distributed execution technologies were integral to the first 3 steps of the process. In the first step, we automated the calculation workflow using portals, while also defining the necessary compute resources for each analysis. In the second step, we set up the variables and responses, and in the third step, we connected these parameters to specific portions of the input and output files, which had previously been parsed through the portals. The efficient search technology became our focus in steps 4 and 5. In step 4, we defined the study type and adjusted additional settings to tailor the exploration process. Step 5 involved running the study, allowing us to evaluate a specified number of designs and effectively explore the solution space. Finally, the insight and discovery technology came into play in the 6th step. Here, we applied advanced post-processing techniques to transform the raw data into meaningful knowledge, offering valuable insights to guide decision-making. Thank you for watching this introductory video. For more information on the various features, applications, and utilization of the Simcenter HEEDS solutions, please refer to the various videos and knowledge articles available in Support Center, and check out the dedicated Simcenter HEEDS trainings available on Siemens Accelerator Academy.